So for those of you who used Google Classroom in another one of my classes, I did set up this one a little bit differently. I found that it was a little hard for some people to find things. So I tried to make it so on assignment 1, on the tab under assignments, you have week 1, set and drift. If you click that, you have the blank assignment, you have the answers, and you have the YouTube video, all under that same little tab there.
Great.
So,
Okay.
Yeah, last time I had it at the bottom and it all kind of got out of order. So if you're looking for stuff, that might be a little bit, tried to make it a little easier.
Okay.
Oh, I was like, I know there was something else on my list. The running fix. You guys had asked for running fix problems.
Yes,
so
thank you.
I got 3 running fix problems on the training chart. So I tried to take a picture of it and highlight it for you guys. I don't know if it's kind of a hard thing to look at, but yeah, hope that helped a little bit.
It totally helped. Thank you.
Good, good.
And Bree, where was that put? Oh, I see. Okay.
So that's going to actually be on the CoNav2.
Okay.
So
great.
it's just
Thanks.
at the top running fix practice problems, not really under a
Super. Thank you.
topic. So so yeah, give those a shot if you want. Other than that, let's see. So today, I think that's all on my list for announcements. We are going to do the assignment number 2, the 2-day cruise. So we're going to work together on that as a class, and then that's going to be all. We don't have any new PowerPoint today, but I am going to do a little review on my whiteboard. And then next week, we're going to do how we calculate current. So right now we're kind of figuring out what the current is, comparing our DR to our actual position, and we can figure out what the current is and then use that going forward. Another way to figure out what current is using a nav publication, an app, a computer website, something like that. And so we're going to figure out longhand how to do it using the nav or the tide tables. We kind of only have time to do the tides. I did post an example of how to do a current problem. They are very similar in their steps. So hopefully we'll get to an instructional current problem, but in the last classes that I've taught, we've run out of time. But I do feel like the online thing, we actually make better time than we do in the classroom. So we'll see how this one goes. But yeah, next week we're going to be doing calculations, and then the next week we'll be doing a little bit of electronic navigation, and then our final. So yeah, let's get started on our little review here. Let's see. Okay, so I have my whiteboard. So I always create my table of my course made good whenever I'm doing a vector triangle. I have course made good, speed made good. Then I have my boats course and my boat speed. And then I have my set and my drift. So we have 3 lines of our triangle. We have the overground. None of my markers are working. Overground or made good. We have the boat. And then we have the current. We have our 3 legs, and we have to make sure what we want is specific for each leg. We can't use our boat course for our course made good, or our made good speed for our boat speed, or vice versa. So we want to make sure we keep these lines separate. And that's why I like to make the table, just to help me organize all of these directions and all of these speeds. So I like to make our table. And then we always do that common sense check. Does it make sense if we're headed in this direction and the boat is the current is pushing us this way? My made good will probably be something like that. Or if I want to make this good, I'll have to steer into the current in order to make that good. So whatever your desire or whatever, you always want to do that common sense check. So did anyone try the lapware ones? So I forgot, I wanted to tell everyone before the end of class, but I don't know, I forgot. When they had leeway, right? Leeway is due to the wind, and wind is from. So current is to. Wind is from, and then we always apply our leeway. So I guess I'm just saying here, apply to your course made good, and then go to the vector triangle.
Oh.
So they said,
yeah.
I don't know, we want to make good 045.
040.
Is that a question?
Yeah, that was what I was playing with.
Oh, okay. Tell me, read the question. I don't have it on me here.
Hold on a second. It says you are underway and intend to make good a course of 040 true.
Okay.
You experience a current with a set and drift of 190 degrees true and at 1.4 knots. And a northwest wind produces a leeway of 3 degrees. You adjust your course to compensate for the current and leeway while maintaining an engine speed of 10 knots. What will be your speed made good over your intended course of 040 degrees true?
Okay. So in this one, our missing factors are our speed made good and our course to steer. So we're going to apply 3 degree leeway to our course made good and then plot it on the radar, the radar transfer sheet. So if we wanted to go 040 and we had, oh shoot, I didn't write it. You said northwest?
Northwest wind, yeah.
Northwest wind producing a 3 degree leeway. So the northwest wind is going to be coming from the northwest from the northwest. So our wind is going to be blowing that way.
Right. Okay.
So in order to compensate for that, we want to steer into the wind. So our course made good is going to be 037.
Okay.
So we just apply our 3 degrees to our course made good. So we change that to 037, and then we go to our our radar plotting sheet, we have 090, something like that. And then we swing our arc for 10 knots. And then we can get, so we know that this is 10 nautical miles. Then we can get our made good line. Do you want me to do that on plotting sheet? I just looked at this. I'm like, that's really sloppy. Let's do it. It's a good review here. Okay. So I have my course made good, speed made good, my course, my speed, and then my set and my drift. My course made good, I wanted to do 037. My set was 190 at 1.4. My speed is 10. So I'm going to use the 12-mile scale because I have a 10. I'm going to draw from the center those two things. So I start at 370, or excuse me, 037. And then I do 190. My 190 is 1.4. So we have the end of our current line. This is our made good line, but we don't have an end to it. We don't know where it actually ends. And then our third line that needs an ending point here is going to be our boat. And what we know from our boat is that it is 10, our speed is 10 knots. So we go from the end of the current line, not the center, because that's where, to keep it different from our made good line, right? Because it's not in the same little bracket here.
Yes.
So there's our 10. Then we can connect the two. And get our course to steer. Our course to steer being 033, which makes sense if we want to make this good and the current is pushing us this way, we need to steer into it. And then I think the question was, what was our speed made good? So now we have the end of our speed line. So we could measure the length and get what our speed made good will be. So I got, what do we have? 8.7 as our speed made good. So it's going to be slower because that current's pushing almost on our bow. So that makes sense, it being slower than what my actual engine speed is. How close were we to the answer?
Good, within one.
Okay, there we go. All right, did that make sense?
Yeah.
Okay. I think I had, okay, I don't have the homework or question quite in front of me, but maybe you could help me out, Tiara. Can you see a question on Lapware that has a set and drift and what the boat was doing, and it's asking us for the made good?
For the made good, I didn't, yeah. Oh, speed made good or course made good?
Either one.
Oh,
But
okay.
it gives you what the boat is doing.
You want what the boat is doing. Okay. So I'll do number 13. And it says you are underway on course 160 true at 10 knots. The current is 210. Oh,
Yep.
current is 210 true at 0.9 knots.
Okay. Thank you. Okay, and this was number 13, you said?
Yes, 13.
Okay. Okay, so they gave us a set and a drift and our boat's course and our boat's speed. What starts from the center is our set and drift and our current, but we have no numbers for current. So we're going to start with set and drift. So we have 210 at 0.9. Let's find 210. Okay. At 0.9. Okay. So this is the end. This is the beginning. So this here is our current line, right? It's pushing us this way. And then we have our boat line that is 160 at 10 knots. And we know it does not start from the center. So if it has to make a triangle, it starts from the one that is not the center. So it starts from this one. So we'll find 160. See, I'm using the center to find 160, but then I have to parallel it to that other dot so I can draw it out. So I'm paralleling it to the end of my current line, and I'm drawing out 160. So it doesn't cross through 160 because I paralleled it over. I know the length of this leg is 10. So I need to measure. See anything? So from the end of my current line, I measure 10. So that this is my boat line. The direction was 160 and it was 10 nautical miles. So I have the end of this line right there. So then I could connect these two to get what my made good is going to be. So I got a course of 164. And the speed is going to be bigger than my 10, but by how much? Let's see. Let's see. About 10.7. for my speed made good. So let's see if it checks out. If the current is pushing in this direction and my boat is headed in this direction, my made good, let's see, is this making sense? My made good would be 164. So this is where my boat is headed, 160. 164, it's pushing me a little bit to the south. So that does make sense. And my speed, it's pushing a little bit abaft the beam. So I'd be making better speed than I thought I would be. And I'm doing 10.7 instead of 10. So that checks out as well. Any questions on that one?
Yeah, I don't get it. The current's pushing you that way. It seems like you'd have to start, to get to that point, you'd have to start out the other way. You'd have to start out 1 point, whatever, there it is, in towards the wind. You're starting out below the wind and the wind's pushing you that way.
So,
like, to me, it doesn't make any sense.
So let's see, let's make it so we have our 160 on here too. Okay, so this is my boat's heading, is 160.
Okay.
Right, this one right here.
Okay.
And the current is pushing me this way, so my made good line is this one.
Okay.
So it's pushing me. I'm not compensating for it. I'm just letting whatever happens, happens.
Right.
So the current is pushing me towards 210. So if I'm at 260, my made good is going to be, you know, on this side of 260. So it's 264. As my boat travels. It's a very small margin, so I feel like it's a little bit harder to see.
What I did for all these problems, I made a parallel line of that drift of the current, and moved to the end of the journey. Okay, so it's basically so I don't, in that case, I don't have the same confusion as Milo has, right? Because I'm starting point is always in the center of the circle, right? Mm-hmm. But I'm traveling along that line, the line on the right instead of the line on the left. So
yes.
So there's less confusion.
Yes, and that is also a great way to do it on the chart. Yeah. You definitely have to do that common sense check to make sure you're not compensating the opposite way, one way or another. But yes, that way works as well. We're just kind of creating this triangle of having all these vectors affect one another. So you can, make it the opposite way and you still get the same answers. I tend to teach it here where these two are always from the center, just so it's consistent and it will always work out. But I can see how it can be confusing sometimes.
Okay, for my sake, so the line you want to go on is the line from the center to like, I don't know, what is it? I can't see it, down to the bottom, right? That's the line you would want. That's like your DR line, right?
Yes, so I would put my DR line as 160. It would be tricolors.
So this other line that you drew, the one that with the current, the compensating for the current, that's the line you want to go on? Oh, gosh,
so
Which line do you want to go on? You want to go on the 160 line?
Okay, so the green line is what our boat is doing. So that's our DR line. The current is pushing us. So what ends up happening is that we end up making good this pink line. That's what happened over ground.
So the pink line shows you're really not compensating for anything. The wind is just pushing you.
Correct. We are not compensating for anything.
Okay, it just shows you how much the wind would push you, the wind would push you, and then you'd end up below what you wanted to go to. You want to go to 160, and now you're at, I can't see it, but whatever it is.
Yeah, 164.
Yeah, 164. Okay.
Yeah. So in this problem, we're not compensating for anything. We're just,
all right.
I was steering this course and this current happened. Where did I end up?
Okay, all right, all right.
Yeah. Okay. Let's dive into the homework assignment and see if things make sense. Okay.
Can we go back to this one just one more second?
Yes.
Okay, so this other line you drew where you took the current, you drew a line for the current, right? From the center, you drew to the current, right?
Yeah.
That line there. And then you drew a line from there to this point, down here, 164.
Yeah.
So if you took that heading, but you started from the center, you would end up at 160, correct?
So
that would be your compensation. That would be the line you would compensate for because of the current.
So in this question, it didn't ask us to do any compensating. But
I know, but just for me.
Yes.
That line right there, that you just drew on, if you started from the center, you started from the center, not from that point, but from the center, but with that heading and that speed, would you end up at 160 then?
So this line that's not the pink line.
Yeah.
Zoom in a little bit more. Okay, so I've kind of made a parallelogram here. So what Fred was talking about, that he just drew the 10 nautical miles at 160, and then put the current line at the end of it, and then went back to the center to find what the made good would be.
Okay, that makes sense.
So here's a triangle. It's the same as this triangle. So it's a parallelogram. You can draw it either way.
All right, all right.
So this one is the one that I drew. I'm trying to shade this in. The lighting's not great here. Or you can draw it that way. Either way works.
Okay. Okay. I think I'm getting a little bit.
Okay. Good. Okay. Put that down. Let's So our homework assignment 1, or excuse me, homework assignment 2 starts off with kind of this little refresher here. What is the title of the chart? What is the scale of the chart? So that's all right up there in our chart block information. And then it tells us we depart Newport. So Newport, our NWP buoy, We always go from our NWP buoy. Let me try to get the light on. There we go. So and we go from there at 6:12, and we're en route to Edith Oil Island, approximately 2.2 knots. So our Edith Oil Island is over here. So we are going out for a fishing trip, and we will learn that we don't catch any fish. Spoiler alert, but we're going to plot a course from Newport Buoy to Edith. That's our first step. Don't have a flat surface. All right, I think that's a dark enough line. So I went from NWP to Edith, drew my line. Then I want to find my course, or I'm going to write in my course, my distance, my ETA, etc. So my course, okay, I'm going to have to stand up. I can't read this. Reading a course here of 273. So I have a course of 273 degrees at a speed of 12.2. I'm going to get my distance. I know it's over 5 miles, so I'm just going to start with 5 and then walk it out. So here's 5, 10, 10 plus 3.1 gives me a distance of 13.1 nautical miles. Okay, so this is just our basic Coastal Nav 1 stuff so far. What is our estimated time underway? So we go back to our 60D Street. Hey, here we go. Look. Trying to hide from this light thing. That's annoying. Okay, so we have our distance was 13.1. Our speed was 12.2. We are looking for time. So when we plug it in to our equation, we're looking for time. So we have 60 times D divided by S equals time. That gives us 60 times 13.1 divided by 12.2 gives us time. Gives us 64 minutes. 64.4. So
yeah, I think we got a little bit measure error in mine. I got 13.2, so that will give you the
Okay.
1 hour and 5 minutes exactly.
Okay.
Yeah.
So 1 hour, 4 minutes. That's totally, yeah, I'm a little bit off from mine, but definitely still makes sense. So if we left our buoy at 612, what is our ETA to Edith? So we have 612 plus 1 hour and 4 minutes, or 5 minutes, however your calculation went. And then, so that gives us 16, 0716 as my ETA. Okay. Is everyone following along? Are you guys plotting? I know I did mine real quick. I want to see if you guys are plotting along as well. Then it told us a short time later, you encounter a short time from departure. You encounter 00 fog. Of course, you're prepared for this, as you always know that Murphy is on board with you whenever you are underway. You and your radar are on standby and now switch to transmit. All is clear ahead and all around your boat. A few minutes later at 7:17, you take a range to Edith. You take a range reading to Edith is 1.8 miles distant. At the same time, you take another range at Eureka and it is 0.9. What is your fix? So we thought we'd be there at 1717 or 1716, whatever it is. But we ended up someplace else, but we need to plot that position. So we have two ranges. So our ranges was from east 1.8. So I'm going to get on my compass here 1.8. So here's Edith. I'm just going to swing an arc here. I'm somewhere along that arc at 1.8 nautical miles. And then Eureka down here is 0.9. So I'm going to get that on my compass. So
Ray,
where the
I got a question right there. Actually, you could have 2 points, right?
Correct.
Yeah. So how do you determine which one is the one we are? Yeah. Both are possible.
I have a note to say add a depth to the question. I guess that's what this actually, because you can have two possible,
yeah,
you're right. You could have two possible ones. It doesn't give us any more information in the question. So yes, you could be here or here. The question needs to be edited to let us know that we haven't passed the oil rig yet. We are on the easter option of where we think we are.
Yeah. Well, what do they mean by 00 fog?
Can't see.
Zero visibility.
Can't see anything. Okay.
So those distances just come off your radar then? Is that the deal?
Correct.
Okay.
So on your radar, you can get, let me show you here. Can I zoom in on this? Well, I'll just share it. Okay, so this is a picture of a radar.
Okay.
And these rings, so I am at, it's not exactly the center, but this is where the vessel that I'm on, and everything that's projected out is away from me. So these rings are called variable range markers, and that's how we get our distance to things. So that's the most accurate way you could use your radar about getting distances. So it's getting a distance to this Raycon right here. I don't know if we learned about it in CoNav2, but our Raycon has a specific symbol
Radar
that
symbol,
is in
yeah.
Morse code that is projected away from us. So we have a distance to the Raycon of 6.3, and then we have a distance to this target here at 7.6. And it goes, 7.641 nautical miles. So they can be very accurate. So if you had the two, oil rigs are very great radar reflectors. You can get a quick distance from each one. So hopefully on your radar, you can see if those oil rigs are to the east of you or to the west of you. Have you passed them or have you not passed them? To help you decide between our two, oops, I stopped it. Here we go. Our two possible options for our position. Go back to a light. Okay. So,
Bree, could I ask a quick question? Could you just go back? So when you took the heading or to try to pick the position for the Eureka Oil Island at 0.9 miles, you took that off of Edith?
Edith was 1.8.
Yep.
And Eureka down here was 0.9.
Okay. So you're plotting, you're taking your 0.9 miles off of Eureka. Got it.
So
okay.
Here's my 0.9 and I swung that arc.
Yep, got it. Thank you.
Okay, it asked us what our latitude and longitude is.
So Bree, so that's just a regular fix. That's not like an electronic fix.
If you're using your radar, it would be electronic fix. So it would be a triangle. Okay. But I just
all right, thanks.
Trying to make things more visible with this lighting.
All right.
It's been frustrating for me. Trying to make things bold so you can still read it. It gets dark so early these days, right? Okay, so that's our 17 position. Our depth, okay, so it asks for depth. It doesn't give it to you. I need to. Okay. So then it asks us, did we experience a set or drift? If so, what was it? And what was our speed over ground and course over ground? So we thought, so our DR was at the end of Edith. We thought we'd be there at 07:17, but we ended up here. So this is our DR, and this is our actual position. So this was what we were steering. This would be our boat's line. And then from our actual position and another actual position, there we go. You see it? We can see it. This is our made good. So we have our made good line here, our boat's line there. So that means if we connect these, the end of this point and the end of this point, we can get what our current was, our set and drift. So we could connect those dots. So I'm connecting from Edith to that actual position. Can't see it very well.
Yes, we can see.
Okay, so now I have my triangle, and now I need to fill out what they're asking for. So they're asking for a set and a drift and a speed over ground, course over ground. So let's look at our current line first. If we thought we'd end up here, but we actually ended up here, did our current push us this direction or this direction? So was it northwest or southeast?
Southeast.
Southeast, right? They pushed us southeast. So I know my current value is going to be somewhere between 090 and sorry, I have to move this 180. Moving. Hopefully you guys can still hear me. Geez, please. Huh, I have exactly. Oh. There we go. So I am measuring, oops, I bumped it, measuring here my Edith. So I have my focal point on the line. I have this line through Edith and through my actual position. Then I could read down here. I have 300 and 310 or 2 or 120 and 130. I know that it pushed me southeast, so I'm going to be in between that 120 and 130, and I get 126 as my set. For my drift, what did I do with my drift? There they are. For my drift, I get a distance of 1 point, we'll call that 1.8.
A quick question. If you got 126 for your set, and as an example, I got 134, is that pretty significant for error?
I say for the set and drifts, you want to be plus, where's my paper? Actually, I have it. plus or minus 10 degrees, actually. So I guess that wouldn't be too far off. The thing with the set and drift, sorry. Okay. The thing with the set and drift is that it's such a small line, you can move it one way or another and get a wider margin of error. If you are taking a Coast Guard exam, you'll get your answers, I need that to go away. A, B, C, D. You might get, so I got 1, 2, 6. You might get, and my distance was 1.8. My actual speed was 1.6. So examples for answers from the Coast Guard would be, yeah, 135 at 1.8. I'd call it 1.9. I'd call 120 at 1.7, and then I would call it 300 at 1.7 and 320 at 1.9. So this is how the Coast Guard splits up their questions. They split it up basically, was it pushing you this way or was it pushing you this way? So that's why you want to know current is 2. So right off the bat, you can eliminate 2 of your answers.
Understood.
Because I know the current was pushing me to the south, it won't be pushing me to the north. Then I have to decide which one my speed is. When you do speed, they typically feed you the answer of what the distance is without converting it to speed, without doing 60 straight. So I put in 1.9 and 1.7 because that would be the answer for distance only. If you convert it to speed, you get 1.7. But your actual set will be off. So I wouldn't go with which number your set is closest to. I would just go to, is it pointing southeast or northwest?
Okay.
So that's a quick Coast Guard way of doing set and drift problems. But in our case here, we figured out our distance, our leg, our distance was 1.8 nautical miles. We need to convert that to speed. Speed is our question because we're looking for drift. And what time was this interval? So our whole triangle is from 6:12 to 7:17. So we need to do a little math here. So we have 7:17 minus 6:12. I think we already did this math, right? 1 hour and 5 minutes, which is give us 65 minutes. We plug this back in to our 60 D street. So we have D equals, nope, we're looking for speed, excuse me. 60 times D divided by T gives us speed. 60 times 1.8 divided by 65 gives us 1.66. So this is our drift. So most of the time when we do a set and drift problem on the chart, it's not in that perfect hour where when we were practicing last week, it was easy to do that conversion of speed and distance because we set it on the hour. But most of the time in practice, it's not going to be exactly on the hour like that. Okay. Our next question on here. Was what was our course over ground and speed over ground? So we're looking at our made good side of this triangle, and I want to see what my course was. So I line this up. There we go. And I get a course of 268. Oh, there we go, 268, yep. That's my course. And then I want to get my speed. So again, with speed, we can get our distance, then we have to convert it to speed on all points of our triangle. So I just set my dividers to 5 miles. We'll start here. 5, 10, 11.7. I got a distance of 11.7. And do the workout on this one. I had a distance of 11.7. My time was 65 minutes. What is my speed? So 60 times D divided by T. 60 times 11.7 divided by 65. I got 10.8. So on this one, we converted again. From our distance to our speed. Okay.
So I got a question.
Yes.
Before we were talking about leeway as though it's separate from set and drift. But it seems like when we calculate it this way, it's combining both of those, well, all three of those effects. So how do we, how and when and why would we separate out?
So
well, different vessel, yeah, okay. Like I guess if you're, instead of doing this way, like looking back on where you started where you ended, if you were trying to plot out where you're going in the future, I mean, you would look up in a chart and see information about currents, but each boat or ship would have its own leeway, I would think. So how does that enter into all of this?
So when you have the two different things of current and leeway,
yeah,
you're getting that information, most likely you're getting this information from the nav pubs, and you're getting this leeway information as if it's for your boat specifically. If
okay.
you know that if it's blowing 20 knots, you have to have a leeway, you have to head into the wind 2 or 3 degrees, or 5 degrees if it's 30 knots, or 1 degree if it's 10 knots, whatever it is specific for your vessel. So that's going to be vessel specific.
How
So
do you,
then when you are trying to compensate for one of these
Yeah.
things, you can combine all of them together, leeway and current. When
Okay.
we're doing kind of finding the difference, not using the nav pub, but finding our current, we're calling it, or set and drift, from comparing our DR and an actual position,
Yeah.
we're grouping in swell, leeway, current,
Yeah.
everything together.
So how do you find out your specific vessel's leeway? Or just is that just from?
I would say just experience on the vessel,
Yeah.
that, you know, and I want to say you could, you know, if you're going from one vessel to another vessel, I call it sail area. You know, do you have a large house structure that is very tall and it's subject to that sail area more so than a, you know, deep draft, very low sail area? Maybe it's just one single house and the rest of the vessel is underwater. They would be more subject to the currents.
Yeah.
I also use just a quick rule of thumb, I guess, out there. 30 knots would be equal to 30 knots of wind would affect us the same as 1 knot of current. That was specific to our vessel. So you're kind of looking at both, yeah, the wind and the current and compensating one way or another. But also, as you are going, you can adjust, you know, as if you, okay, so typically you'd have some sort of electronic plotter, and you can see real time if you are on your track line or not on your track line. Yeah. So you could be adjusting and kind of figuring out what that adjustment would be.
Mm. Okay.
Okay. Hope that makes sense. Okay. Oops. I'm gonna try to focus this a little bit. Okay. Are we ready to move to the next problem? So our next one tells us from our 717 position, you end up drift fishing. So that means our boat vector would be 0. We're just drifting for 42 minutes while we find ourselves next to the Eureka Island, oil island. What current did we encounter? So from here, in 42 minutes, we end up right here at Eureka Oil Island. What current did we encounter? So our course over ground and our current are going to be the same line because our boat vector is 0. We were just drift fishing. So I'm going to connect these two positions. Can I see that? And I want to get the set and the drift. So our first step is to get the direction. Gonna need a ruler. Okay, so I know that it's pushing me towards the south. So I'm going to be somewhere around the south, and I got 195.67, 197. All right, we got 197 checked out. And then I want a speed. So I'm going to get the distance here. And this distance is in 42 minutes. So I do need to convert it back to a speed. So my distance was 0.9. My time was 42 minutes. What was my drift? What was the speed? 60d divided by t gives us a speed. What did you guys get? I'm gonna wait for you guys instead of doing my calculator.
1.4.
I got 1.3.
1.4, 1.3, close enough. Two answers that are close enough. So if we are looking I guess I'm not going to dive into it too much. Okay. Yeah, I'm just going to leave it at that. Okay. Are you guys with me so
Hey,
far?
Bree.
Yes.
Bree, on the next question, at least on the answer sheet, just wanted you to know that there were some differences from the homework. So on the answer homework you posted, deviation was 2 east and 12 east for variation. And at least the homework in my packet had deviation of 3 west and variation of 13 east, just FYI.
Okay, let's get into that. I have my deviation table here, so let's figure that out. Okay, so from here, we've been skunked. We haven't gotten any fish. So we're gonna head to another hot fishing spot at 14 mile, what is it called? 14 Mile Bank. Okay, I'm gonna have to zoom out. So down here is our 14 Mile Bank. And we have a Latin long. So first we need to plot the Latin long to figure out where our destination is. So let's do that. Keep moving stuff around today. I have a small work area. Okay. So we have 3323.9. And then we have a longitude of 59.8. Okay. Reading that right, isn't it? 9.8, okay. So brighter here. Okay, so this is my final destination and I'm leaving Eureka. So I'm going to plot my line. Okay, so I need to plot, it asks us actually, my speed is going to be 10.7 knots. We're now assuming there's no set and drift. What is the true heading? If deviation is 2 degrees and you find that variation is 12 degrees, what is the compass heading? Why did they give us deviation? Now I understand your question. Okay, let's see what let's see what our true course is. I got a true course of, write it this way, so 149. I got 148. Close enough. I got a true course of 149 degrees true. So if I use my deviation table, I have variation of 12 east, and I am looking for 149. I would have used 1 east. They are giving it to us as 2 east.
Bree, at least in the homework packet I got, they're giving it to us as 3 west for deviation.
And that's
And I'm
given
just
to you.
reading from, yeah, in the question itself says, if your deviation is 3 west and you find the variation is 13 east in the homework packet.
Okay. Well, we are not going to do that.
Oh, okay.
Sorry. This class needs a little editing. Okay. I don't know why they would do that, because we have our deviation table. Did it say at the beginning use the deviation table? I guess it didn't.
No, at least on my sheet, it doesn't.
So let's say use the table. Okay, I apologize for the mistakes on this. How I would do this is use my 149. We have true. So I have 149 true. Oh, maybe it did work. My variation was 12 degrees east. So I'm going to be subtracting that 12. And I get
137.
Thank you. 137. I go to my deviation table. With magnetic heading at 137, I get a deviation of 2 east. I guess that was right, but it's confusing. 2 east. With that east, I'm going to be subtracting. So I get a compass course of 135 degrees PSC. Did that make more sense for everybody? Okay. Then it also asked me what was my distance and what would be my time run if I'm doing my 10.7. So let's get distance. Five, 10, 10 plus 1.1 would be, no, 1.6, 1.7, 11.7, that checks out. My distance, 11.7. Using my speed, my distance, I know I'm going to be a little bit over an hour, but let's do 60 D Street. We have a speed of 10.7, a distance of 11.7. What is the time? We'll call it 66 minutes, 1 hour, 6 minutes. That's what I got. All right, that checks out. 1 hour and 6 minutes. There wasn't even a set and drift question in this. Okay. Let's take a quick 10-minute break. And then we're going to come back and do our transit from our fishing back to Catalina. Does anybody have any questions so far?
So far, so good.
All right, then let's come back at 8:05.
Yeah.
All right, I just read through the homework. I should have done it before class. But yeah, that one sounds interesting. We're gonna do it. Okay. Okay, so okay. So we ended up fishing around here. Many hours later, we still haven't caught any fish, but we plot a position at 8:15, and then we head back towards Catalina. So we want to plot our 18:15 position. Let's see if I can zoom in. Okay. Our 18:15 position. 18.4. And 118.07. I guess you can't see anything that I'm doing. There we go. 7, what was it? 767.85. Okay. So here is my 18:15 position. And at this point, we head to Long Point. Let's go back up here. Okay, I'm just gonna stand up. Okay, so here we are at 18:15, and at 18:15, you head for Long Point. So Long Point's up here, and reduce your speed to 10 knots. So we're going to connect our 18:15 and Long Point. And we have our speed at 10 knots. Okay. We're going to get our course. See, I got a course of about 292. Nope, that's wrong. 297. That would make more sense. 297. At a speed of 10 knots. So I set a course. So my heading is going to be 297 degrees. And then it says at 1841, we lose sight of Catalina West End Light, but let's plot our other two first. At the same time, we see Long Point bearing 005 degrees relative. We also see Light 2 345 degrees relative. Now with our relative bearings, I'm going to say in reality, it's going to be very difficult to actually get a relative bearing this accurate unless you have some sort of tool that measures that. But this is the way the problem is. So let's plot it out. So my rule of thumb for relative bearings, if we are going here at 297, put that up here, 297 degrees, oops, we are headed in the direction of 297. Now, if I saw something relative, it's going to start going counterclockwise. Oh, excuse me, clockwise, not counterclockwise. So my 005 is going to be 5 degrees clockwise. And then my 345 is going to be 345 degrees clockwise. So in order to plot these two LOPs, we need to get them in true so we can plot them on the chart. Now, my rule of thumb for this is R plus S equals T. That is, let's see if this works, relative bearing plus your ship's heading equals the true bearing. So in this case, we have Long Point with a relative bearing of 5 plus my ship's heading of 297 gives me a true bearing of 302 degrees true. Light number 2 is 345 plus 297. I can do that in my head. It's going to give me a very large number. 345 plus 297 gives me 642. So on my boat, here's my true, my 0. It's going 360 degrees plus minus 360, another 282. So it's ending up right about there to get my 642. So my 642 minus 360 gives me 282 degrees true. So I'm going to plot these two LOPs and see where that leaves us. Okay, I'm going to plot it and then I'll show you that whiteboard again. So our long point was 302.
Bree, on that one, your head's blocking you. Just if you could
Oh,
kind of
shoot.
really show that one.
Yes. Sorry. I'm gonna plot it this way so you can see it. Okay, so I'm looking for 302. Now I'm gonna have to extend this. So this is 302. That's the bearing of that. And then my next bearing was 282 on light number 2. So that's the north light or westerly light. So here we're looking for 282. Gonna extend it out. I jiggled. Let's try that again. Shoot, my head. There's 282. Extend it down. To 82 degrees true. So let's bring the light back on. Try to zoom in on this. Focus it. Okay. So let's talk it out again. I converted, I hate these lights. I converted from my heading, I converted my two relative bearings to true bearings so I can plot them. So it was R plus S equals T, but even if we didn't do that math formula, we can visualize it. If it was off my starboard bow by 5 degrees, it would be 302. And if it was essentially 15 degrees, because 15 degrees off my port side, I would have 15 minus 270 or 297. That would give me my 282. So I have something bearing right off my starboard bow and then about 15 degrees off my port bow. So I plotted those in true, and then I can plot those LOPs. So,
hey, Bree,
yes,
I've got 6 tools here and I'm trying to keep up. Can you pause and maybe focus where those LOPs are so we can make sure that they're right? You know, the lines that we're drawing with the triangles while we're trying to watch you draw the lines?
yes. So long point was bearing 302. So I brought in put my pencil on long point.
Yeah.
And then I'm going to pivot and line up my focal point. Oh, it's easier for you guys. This one's easier to read, isn't it? I think it's a little easier to read. So I put my focal point and then I'm looking for 302. So here's 300, 302. Let's see if I could zoom in a little bit.
Thank you.
Yep. All right, I think that's as focused as we're gonna get it. Let's try this. There we go. So hopefully we can see we have 302 at the top. It's in line with my long point and the focal point. So I put pressure against it. I draw this out, and I know I'm also going to be seeing kind of the end of this east end point. So I'm going to extend my line out a little bit. And how I did that was just use a ruler, slide down. So I still have it on long point here. And I can draw in my bearing line of 302. So let's try to make it dark here. So this is my bearing line of 302.
Great.
And then from my light 2, so that's going to be this light here. So the one on the north side, if you will, north or east side, excuse me, northwest side, is going to be bearing 282. So I'll put my pencil on the light in question, and then I'll find 082. So I have my focal point, and then 282 on the edge of the triangle there. It doesn't go quite far enough, so I'm going to parallel it out a little bit more, and then I could draw in, try to make it thick here. This line here is 282 degrees.
The break.
Yes.
The dot line going through the Catalina east end lights. I assume that's a line you're gonna lost the sight of the light tower, right?
Correct. So this little
Somewhere.
arc here is giving us where it is obscured. So
Right.
it gives us this dotted vector line
Okay.
that says anywhere on this side of that line, you won't see this light.
Okay. So that's another hint that we must be on
Yes,
that line somewhere.
somewhere on that line.
Right? Okay. Thank you.
So we can call that we have this line, and this line all meeting to give us an 3-point LOP right there. And that was at 1841. So we were here at 1815, and we're here at 1841. So we've drifted to the south of our intended course line. How are you guys doing on it? What's your tricky part?
keeping up. It's
Oh gosh, okay.
you're trying to look at the chart at the same time you're trying to look at the look at you.
Look at the screen. Okay, I'll slow it down.
No, I'm good. I'm just telling you that's it's almost like I need to. Well, anyway, good.
Bree, actually, that really helped, and I got the right answer. So I just got to do that about 28 more times.
Good. Did you use the little R plus S equals T? Or do you just kind of picture it in the circle?
Well, at first I had just measured out the distance with my protractor to get an idea of roughly, okay, at that speed, how far I would have gone. I wound up, that's actually not, and then I just looked for where it crossed the dotted line showing when I lost the sight. So just as a quick down and dirty, it wasn't actually that far off, but then doing RST, I dialed it in and got it 100% accurate.
Cool. Okay. So, as we continue to do this, it did ask us what our current, or what current did we encounter? So I know I'm not on my track line because my track line's up here, but I have to figure out which way it's pushing me. So in order, I have an actual position, but I never actually plotted a DR position. So I am going to calculate out a DR. So from 1841 and 1815, how many minutes is that?
26.
26, okay. Did I mention I'm in Texas right now? It's a little bit, it's later. Okay, 26 minutes. And I wrote 29. Look at that. 26 minutes. So that's our time. Our speed, we're just putting a DR. So our speed is 10 knots. So my distance, I need to figure that out. Still like this light. .33 nautical miles is my distance. Right there. So I want to plot my DR. Okay, so 4.3. Oops, why did I move that? From my 1815 fixed position, I can plot my DR. So this is where I thought I'd end up, and I ended up down here. So now I can create that triangle, that vector triangle. So my DR line or my track line, that's going to be my boat. A known position to a known position, that's going to be the made good line. See what my course made good is. There's my, yep. 288. 287. Okay. Okay, so I'm also, okay, so this is my made good leg, my boat's leg, my made good leg. I know my made good course was 288. I'm also going to calculate what my made good speed is. So I'm just completing my vector triangle here. So my distance was, can I write it in here? 4.5. So my distance was 4.5 nautical miles. Convert that into a speed. $10.4. Okay, so I got a speed made good of 10.4. So I got my boat, my made good, and now I need to figure out the third edge of our vector triangle of the current. So let's connect those lines. Let's try to be accurate here. And I got a current, it's pushing us towards the south, the southwest towards. So it's going to be in between 180 to 70. So I'll call it 215. So I'm just going to write it. What am I going to write it? It's getting sloppy over here. Current 215 degrees true. Okay, I got 226, but I think that's close enough for a set and drift question. And then I want to convert again from distance to speed. Oops. My distance between my DR and my actual position is 0.7, maybe call it 0.75, call it 0.7. At a speed of 1.6 knots. Put that up there. Okay, so I've completed my vector triangle here. I have a set and drift, a course and speed, a course and speed, and a course and speed for all 3 of my lines. So what are your guys' big questions on creating that vector triangle? So when we're doing that on the chart, it's not on the hour. So it's not that convenient distance is equal to speed. We always have to 60 street it back to our speed.
I did it on the hour.
It's on the hour.
I did. I extended. I made a DR line, and then it showed where I was going to be at 1915, and then I knew the course. So I extended that course out, and then I knew my speed was 10.38, and so I just extended that at where I'll be an hour. Then I got my set and drift.
So did you just extend out your course made good line?
Yeah.
Okay. You're just making the triangle bigger. Oops.
What was your set?
What?
What did you
set,
get for set?
So I got a set of 215. My answer set was 226 on the answer.
I got a set of 217.
Okay, I got 215.
I got 217 for what it's worth. I think the answer set might be wrong.
Okay.
Well, I got 223.
Okay. I'll write those down. We got 223, 217, 216. I had 215. All right. Okay, so we're gonna keep chugging along. They asked us what the actual fix was. I'm gonna say you guys can do that. What was the current encountered? Okay, so now we decide to head for Avalon instead of Long Point, since we are so far off course. What is our distance, our course, and our ETA to Avalon? And we're just gonna pick a point in between the 2 lights there. So we're just picking a point, which we kind of already have it drawn out. Our bearing to the to the light 2, right, was 282.
282 relative. I'm sorry.
282
Yeah, 282 true off of a relative bearing.
Off of a relative bearing, correct. So I'm going to go with that as our course. And then we want our distance. So I'm going to get the distance from my 1841 fix to the entrance of Avalon right there. So I think my dividers will reach. I'm not going quite as far as the light, but let's use your best judgment on this. I got a distance of 5.5. So I got a distance of 5.5. Can you read that? And then they did give us a little pro tip here, but oh, they got 5.3. Okay, what 5.5? Not too bad. To use the speed so we can keep projecting it forward, the speed made good that we had from our previous, our 1815, what speed made good if we continue to go to our to Avalon instead. So that speed made good was 10.4. That was what I got. I guess on the answer sheet they had 10.6. I'm going to use my speed of 10.4. What speed made good did you guys get?
10-4, everybody.
I got 10.38. I just left it like that.
Okay.
Yeah, this is a smart way. I didn't do this one. I basically just draw another current line, calculated the how much the current drift going to be. Then, okay, and use that 10 knots as the DR.
Okay, so you made a new vector triangle here.
Right. Yeah.
So I'm just kind of tagging on from the old one.
Yeah, which is more convenient, I guess.
Okay. That makes sense. Okay, so I'm going to use my looking for time, 60d over speed. What do we have here? 60 times 5.5 divided by 10.4 gives me 32 minutes. 31.7, calling it 32 minutes. So I would say, change to green here. If we started at 1841 plus 1841 plus my 32 gives me 3, 7, carry the 1, 1913 as my ETA. Then we get to Avalon, we find a mooring. and we turn in for the night. Okay, let's see everybody here. So we can go to day 2. Our first 5 questions of day 2, we are leaving Avalon and kind of cruising around the coast of Catalina, and we get a couple of those relative bearings. So I can do those. Then we head up to Long Beach, cruise around the harbor, and head from Long Beach to Newport, where we're going to do a vector triangle again. So we only have about 45 minutes, maybe 40 minutes left of class. I kind of want to make sure I get to the vector triangle, the end one. Or, so I guess I'm asking, do you guys want to see me do the relative problems or the vector triangle problem? I will do both on the video. Should we just continue on and then you could look at the video for the vector triangle, or should we talk out our vector triangle?
I'd do the just grind through it, and we'll see if we can help you with the calculations.
Okay. Okay, we'll just continue on.
I agree with Patrick.
Okay. All right, moving our camera here. Okay, so on day 2, again, they give us a given deviation, but I'm just gonna pretend that they didn't do that, and we'll check it with our deviation table. Hopefully it all matches, but we're gonna check that. We depart Avalon on course 347. Our deviation, our variation, what is your compass heading? And then it says when we get to Long Point, we have a relative, okay. Okay, so let's start. Turn these off so we can see the whiteboard. So for number 1, we depart Avalon on a true course of 347 degrees true. What is your compass heading? So I first am actually going to plot from Avalon. I'm going to plot my 347 just so I have that on the chart. This one is better for you guys. So from Avalon, I'm just kind of putting my pencil right on the 16 there, that's sounding. Looking for 347. Okay. So my course is 347 degrees true. We can read that. So I want to convert, for to answer question 1, we'll convert our true into compass. So our variation is 12 east. That's given to us on the compass rose here. We are going to be adding west, subtracting east. So we're subtracting that 12.
335.
335. Deviation table. Magnetic of 335. 335 gives us 1 west. So I would say the question is wrong. And then we get a west, we're going to be adding, so I get a compass of 336. PSC is 336. Okay. That one makes sense? Then we have Long Point has a bearing of 270. So these are relative. Has a 270 degrees relative. And at the same time, Light 2 has a bearing of 180 degrees relative. What is your position at 0900? So we can convert these to true because we know our heading in true was 347 degrees true. So we can convert those using our R plus S equals T. But I am going to do it because I already have my 347. I'm going to do it using my triangle. So if something had a relative bearing of 270 degrees, it would be right off my port beam. And then if something was relative 180, it would be directly astern of us. So I'm going to use that quick math here, and I'm going to put my pencil on Long Point, and then I'm going to put this, maybe I'll do it this way so you guys can see it. Excuse me. So put my 90-degree line up on my heading line. And I'm going to draw out an LOP. Then I had buoy 2 was directly behind me. So I can parallel my heading line, because my heading would be directly ahead of me, directly behind me, right in line with that buoy 2, which is pretty dang close to my other line there. But it is a little bit off, right about there is what. So let's bring back the light. So this was my 270 relative. And then this bearing right here, I just drew a little one, was my 180 relative. which essentially is parallel to my heading line, and this is perpendicular to my heading line. Does that shortcut make sense?
One question on that. Why is the light 2 not right on your heading? Isn't it just right behind you?
Yeah, so I guess that was me. We didn't exactly have a departure point. It said you departed Avalon on 347. So I drew my line a little bit further offshore.
Oh, okay.
Instead of drawing it right directly from the light. But that's just how I drew it, because it's very vague in our in that departure point. It didn't really give us an actual point. I guess that's another correction I can put in.
But for example, if you did it like me and your heading went right through light 2, then it would be on the same line.
Correct.
Okay.
Correct. So you just would have had your relative, and where those two meet, that's your position.
Yep.
Okay. Okay. So then it says, at that point, you decide to head for buoy 1 off LA Harbor. Your new course is blank. What is your new PSC? Speed is 15 knots. What's your ETA? So from this point, we are going to head, and that, do we have a time for this point? 0900.
What did you get for your Latin long for that point?
I did not pop
I
that.
got 33 degrees, 24.7 lat, and 118, 20.6 long.
Okay, stand by.
Same here.
A marker I can write this in? Okay. I got 4, 5, 6, 7. Okay, that was my 0900 position. Okay, so we decide to head up to LA. This over here. let's find our buoy 1 from LA. Is it buoy 1? Day 2. You decide to head for buoy green 1, flashing green 2.5 seconds off of LA Harbor. So green 1, flashing 2.5. So that's the entrance. Can we see this? Yes, we can. Okay. Focus it. Okay, so we are going for this buoy right here, right off the pilot station. So I plotted my track line, deciding to head back to LA. What is our true course over ground? We have 022 is my true course. Let's write that. 022 degrees true. Yes. Kind of goes away. Okay. So we have a true course of 022. We have a variation of 12 east. So we're going to be subtracting that 12 east. And we get 010. Go to your deviation table, magnetic heading of 010. What deviation did you guys get?
1 east.
1 east. We're going to be subtracting that east, so we get 009 degrees as our PSC. Then it told us our speed was 15 knots. So what is our ETA? So we have our course of 022 at 15 knots. We need to find our distance. So I'll start with my 5. From our 0900, we have 5, 10, 15, 15 plus 0.8. So I have a distance of 15.8. My speed was 15. Do it on here. What is my time? So we get
63 minutes.
63 minutes. Thank you. So 1 hour, 3 minutes. If we left at 0900, we're going to be adding 1 hour and 3 minutes. So we get 10:03 as our ETA. Okay. Then it says, after the long haul, you enter LA Harbor, Angels Gate. Okay, so let's look at LA Harbor here. LA Harbor does have a smaller scale, what is it? No, it's larger scale chart. So what chart does it say on here would we switch to? You guys see it?
18749.
Yep. We're going to switch to 18749 and 18751 if we're navigating in the harbor here. So we cruise in Angels Gate. So Angels Gate is that opening in the jetty on the San Pedro side or the LA side. And then we cruise around, what is it over here?
Terminal Island, or in here, San Pedro.
They have all the restaurants and the fish markets, and they're redoing it.
Fisherman's, is that what? I forgot.
I can't think of it now. Anyways, they're redoing it. It's nice. It's becoming a much nicer area. We cruise around Cerritos. What does it say? Cerritos Channel. So that's the backside of Terminal Island here. And then come back around and exit out of the Queen's Gate, which is going to be on the Queen Mary side. And we head for LB buoy. So that is our big Raycon buoy here. Can anyone recognize the shape of that buoy? What is that buoy representing? Oh, well,
Safe watermark.
Safe watermark, exactly. So it asks us what all these abbreviations mean. So see if we can zoom in on this.
I'll try.
Okay, go for it.
So I got, let me see, looks like a flashing white light every 5 seconds, 50 feet above the mean high water tide mark. Can be seen for 14 miles, and it's got a horn.
Okay, so that you're looking at the Long Beach light.
Oh, what am I supposed to look at?
We are talking about a buoy.
Oh.
So the buoy is going to be a little bit further out. Looks like a safe watermark.
Oh, I'm not seeing it.
A little bit further offshore. Has a circle around it because it's AIS.
Oh, I see it.
Has an AIS symbol on it. So it has an RW. That means the buoy itself is red and white.
Yeah.
It's a safe watermark, so it's vertically striped red and white. The LB means it has an LB on it. MOA means it's a flashing light, Morse code A. So dit da, dit da, dit da. And it doesn't give us a color of the light. So the automatic, if it doesn't say the color, it is a white light, and all safe watermarks are white lights. It also has a whistle, it also has a Raycon, and it has AIS. So it is a pretty, we should be able to spot that buoy if we have AIS, if we have radar, and hopefully we can see it. So pretty apparent there. Okay, then at this buoy, we head for the Newport buoy, the NWP buoy. What do these abbreviations mean?
Well, I'll try that one then.
Okay, yeah, try the NWP buoy.
It's red and white, and it has NWP written on it.
Correct.
And then I guess it has Morse code 8.
Yes, and what is that?
It's dash dot dash.
Morse code 8 is going to be the light characteristics.
Okay.
So it's short flash, long flash, short flash, long flash, short flash, long flash. That's the Morse code A. Okay, so we want to go from our LB buoy to our NWP buoy. We want to plot our line. And then it says from past experience, we know set to be 070 true at a drift of 1.7. You depart LB buoy at 1500. You must determine what course to steer and what speed is needed to arrive at the entrance at 1630. Very tricky. So let's go back to our basic vector triangle. Get this down a little bit for us. Hold on. Can you see it? Just about. Okay, there we go. Okay, so I've actually drawn our line from buoy to buoy. My triangle, here it is. Okay, so I want to see what course true would be. And I got 112 as my course. You know what? I'm actually going to do it on here to try to make it.
Thank you for dirty.
Okay. Try to make it simple here. So we have a course of 112. We depart this buoy at 1500. We want to end up here at 1630. We also have a given set that is pushing us in the direction of 070 at 1.7 knots. So I am going to create my course made good, speed made good, boat. So that would be my course, my speed, my set, my drift. Boat, et cetera, et cetera. Okay. So I know my made good course I want to make good is 112. So this green line is my made good line. I have a set, my pink line here, 070 at 1.7. And my boat is what I'm trying to figure out. So my first step in this is going to be figuring out what my speed made good. What speed made good do I need to make? So in order to do this, I get my time difference, 1630 minus 1500, 130, so that gives me 90 minutes. So I have my time is 90 minutes. What is my distance? I need to figure out what my distance is so I can get speed. So let's plot out distance. 5, 5, 10, 15, 16.5. Let's say my distance was 16.5. nautical miles. So I'm going to use my 60D street. 60 times D divided by D equals speed. 60 times 16.5 divided by 90 gives me a speed. Times 16.5 divided by 90.
11 knots.
11 knots. So my speed made good is 11 knots. So I need to figure out what my boat is doing. This is my big question. So in order to plot my triangle, instead of making it a big giant triangle, I'm going to do, I think Milo did it earlier on a vector triangle, is go back to setting it on the hour, because this is at 90 minutes. So I'm just going to try to shorten it up and make it an hour triangle vector. So how I do that is I have my angle for my course made good, right? This guy. I'm going to plot a DR. Yeah, I guess it's a DR for 11 knots. So at 11 nautical miles, then I'll plot this guy at 1.7 nautical miles, 070. So then when I connect, see if I have a different color. I have purple. When I connect the end of this line and the end of this line, I get my boat. So let's see how that works on the chart. Okay. So I plotted my 070 line. Now I want to get 11 miles. So I'm going to do 5.5 on my dividers. So from my LB buoy, I have 5.5 and 11. So right where that 9 is for me. So that's going to be my hour. So if this is 1500, right, 1500, this is going to be my 1600. Hopefully I will make it there. That's my plan. And now I want to make my, so the end of the triangle. I have this dot, and now I need the end of my set line, which was 1.7. There's 1.7. I guess it's more like that. For my set and drift line. And then I'm going to connect these two. Drawing a line. Let me draw it with a mechanical pencil. So we've created a triangle again. And before I even measure it, I'm going to do the common sense check. Where's my boat? If I want to make this good, and the current is pushing me this direction, I need to steer into the current in order to make this good. So looking at this line, you can see that it's angled over. So let's read what it is. My course to steer is going to be this very color coded, did I? Was 120 I got for my heading. And then I want to get my speed, and I've made this on the hour, so my distance will equal my speed. Get 5. Starting at 5 nautical miles. Five. Ooh, just shy. 9.9. So my boat speed that I'm going for is 9.9. Let's look back at. We got to the very end of it. I'm proud of us. I know most of you guys are still plotting here. Oops. Some of you guys had done this prior to class. Did you do this last question a different way? Did you go back to do the vector triangle?
I didn't finish. I didn't get this far, so.
I didn't get this far, Bree.
All right.
I tell you what I always like, I have to think about is like the course made good in the boat. The course made good is what you want to do. A lot of times you have to change the heading on the boat and the speed of the boat to stay on the course made good. But when you draw like two separate lines, it makes you think like, oh, we're over here, but we're not. You're just trying to figure out what you have to do to stay on the course made good.
Correct. So your wake is staying over here, but your boat's heading is going to be pointed here the whole time.
Right.
Right. Here's our heading.
I have to think about it each time because the boat part is just, you're just trying to figure out what you have to do to stay on that course made good. It's not really, you're not really there at all.
Correct. It can be over land, essentially. You're not, that's not where you're going at all. This is just a plotting tool of figuring out what your best heading will be.
Yeah. I have to like wrap it around my head a little bit. The course made good is the same really as your DR. Your DR line, you do a DR line where you're going to be every hour, and that's kind of what your course made good is.
So that would be what our desired course made good is.
Yeah,
When we draw a track line, the shortest point from point A to point B.
right.
But if you're just using a known position and then doing what your heading is and what your boat's speed is, that DR is more of a boat line.
Yeah.
But if you're plotting from buoy A to buoy B and you made a track line,
Yeah,
that would be your made good line.
made good line.
So there's two differences there.
I
Right.
got it.
DR,
Yeah.
it has a known position and it just uses the boat's course and the boat's speed. Track line is going to be buoy A to buoy B, or destination A, destination B, shortest possible distance to get there.
So your
That's what
track
you want to
line is
make
your-
good.
That's your made good. Your track line and your made good are kind of interchangeable.
Yeah.
And just to be clear, and I could have this wrong, but your DR line is your boat line.
Yes. So when you create a DR, you're only using your course and your speed,
Right.
right?
In a known spot.
So if you are adjusting your heading to stay on your track line, then you could use that track line to plot your DRs.
Huh?
Ay. So in this case here, right?
Yeah.
We want to be staying on this. And if I've calculated my speed made good, I could use that as my DR. So it's more, instead of a DR, it's more of an EP.
Oh, I got you.
Look
All
at me
right.
throwing out another acronym at you. Estimated position.
Estimated position.
So estimated position has that one more piece of information, maybe one LOP or set and drift, or one more piece of information. Where if you have two pieces of information, that equals a fix. If you have two LOPs, etc., that's a fix. Estimated position is kind of a, excuse me, kind of this like broad term, I guess I'd say. But the easiest way to say estimated position is just one more piece of information than your DR.
Yeah.
Yeah, that's what I'm going to go with.
Thank you.
You're welcome.
And Bree, this session is on the YouTube thing, correct?
Yes, it will be on the YouTube.
Okay, and I would find that going back to the Google Classroom.
So let's do that right now. So on the Google Classroom,
yeah,
I'm going to post the Zoom recordings, the class recordings in Zoom link and videos.
Great.
So here was our week 1. I will post this one as our week 2.
Okay.
And then I also have a current problem in there. But yeah, all the videos will be in this tab.
Okay, super. No, the only challenge is I'm using parallel rules, so it's a little challenging sometimes. I keep slipping, moving from the compass rose to catch up with you with the triangles. But other than that, I think I'm getting it. So
yes,
just a little more practice.
I would say that the parallels are the most tedious.
So
yeah, I might even say try another one. The roll plotter can be a little bit quicker, and it's kind of that same intuitive of the parallel.
Yeah, understand.
But the more you practice, the better you'll get.
Thank you very much. Have a nice evening.
Thank you.
Enjoy Texas.
Thank you.
Okay. Thank you, Bree.
Thanks, guys. I'll see you guys next week.
Okay, bye.
Bye.